Hello, friends, and welcome to Automation Nation. In today's episode, we are diving into Chapter 4 of the ISTQB Test Automation Engineer syllabus, and we will gonna read about implementing test automation. We will cover test automation development, key principles for building a solid automation solution, risks associated with test development, and test automation solution maintainability. So we'll talk about strategies how to keep our automation framework efficient and scalable. Also, this podcast, as usually, will fully generated by AI using Notebook LM, simplifying complex topics and making learning easier. So let's get started.
Hey everyone, ready to dive deep into test automation engineering today? We're going to break down some key concepts to help you prep for the ISTQB Certified Tester Advanced Level Test Automation Engineering exam.
Sounds good.
I've got an expert here to help us unpack it all, so let's get started.
Awesome.
Okay, so the ISTQB syllabus is really big on starting with a pilot project before you go full scale with test automation.
Right.
In your experience, what makes a pilot project actually successful? Or not?
Well, it really is a lot more than just, picking out your favorite automation tool. A successful pilot project is really all about, setting those realistic goals and defining the scope.
Okay.
So you need to kind of figure out which programming languages your team's actually comfortable with. Are you going to use open source tools, commercial tools? What levels of testing are you looking at automating? And even how you're going to choose and design your test cases.
Wow. So there's a lot that goes into even just that pilot phase.
Yeah, and of course you got to factor in, the team's existing knowledge, any organizational rules you have to follow, and, the specific type of testing you're planning.
So it's like a smaller scale experiment to see what works before you commit to that big rollout.
Yeah, exactly. You want to ironate those kinks and identify, potential problems before they become major headaches.
Right.
And one of the biggest lessons I've learned is that the human factor can really make or break a pilot project. You got to make sure your team understands those goals, they've got the skills,
right,
and that they're bought into the whole process.
Okay, that makes a lot of sense. So, even with the best planning, there are always going to be risks, right? What are some of those common pitfalls that you've run into when you've been deploying test automation?
Oh, definitely. One classic example is firewall issues.
Oh, yeah.
You think you've got everything set up perfectly, and then, bam, your automated tests can't even communicate with the system under test because of some, pesky firewall rule.
Uh-huh.
It's like trying to talk through a brick wall.
Oh, that sounds frustrating. So what other things can go wrong?
Well, resource hogging is another common one. Your tests might start gobbling up all the CPU and RAM, slowing down other processes, impacting performance. And then there's the whole wild world of mobile testing where you're constantly battling things like dead batteries, network dropouts, device compatibility issues.
Oh, it sounds like you need to be a detective to troubleshoot these issues.
Oh, for sure. It's all about being prepared and having those contingency plans in place. That's why a pilot project is so valuable.
Right.
It gives you that chance to identify and address those risks in a controlled environment.
Perfect. So we've talked about planning potential pitfalls. Let's dive into some of the technical stuff. What are some of the key technical risks that you think someone getting ready for the CTEL-TA exam should really be aware of?
Well, a few come to mind right away. One is the importance of packaging your test automation code. Just like with regular software, you need a system for version control distribution updates.
Okay, why is that so crucial?
Well, imagine you're working on a large project with multiple testers.
Right.
Without proper packaging, you just end up with this chaotic mess of different code versions floating around.
Yeah.
Makes it nearly impossible to track changes and make sure everybody's working with the latest version.
That sounds like a recipe for disaster.
Oh, yeah, for sure.
So what other technical considerations are really essential?
Another big one is logging. Detailed logs are like a breadcrumb trail, to help you debug failed tests and understand what went wrong.
Okay, so it's more than just, a simple pass or fail result.
Oh, absolutely. You need to know, the specifics of what happened during the test, the steps that were executed, any error messages that were generated, and so on. This level of detail can be really invaluable when you're trying to, pinpoint the root cause of a problem.
Yeah, so we need to make sure our tests are leaving good evidence behind.
Exactly.
In case we need to do some forensic analysis later.
That's right.
What else should we be thinking about?
Well, test structuring is another critical area. This is where you define how your tests are organized and executed. You got to think about things like test fixtures and harnesses. Think of it this way. Test fixtures are like setting up the stage for your tests.
Okay.
They ensure that everything is in place before the test starts, and they clean up afterward.
So they're all about creating a consistent and controlled environment.
Exactly. A test harness, on the other hand, is like the director of the play.
Okay.
It coordinates the execution of your tests, collects those results, and gives you a nice comprehensive report at the end.
So the harness kind of provides that overall structure and control.
Right.
While the fixtures handle the specific setup and teardown for each test.
Yep.
Sounds like a well-coordinated team effort.
That's a great way to put it. And speaking of teamwork, let's not forget about the importance of maintainability. You might build this amazing test automation suite, but if it's a pain to maintain and update, it's going to become a burden instead of an asset.
So how do we prevent our automation suite from turning into a monster we can't control?
Well, it really boils down to good coding practices. The same principles that apply to software development, clean code, meaningful names, logical structure, they're just as crucial for test automation code.
Okay, so can you give us a concrete example of how, clean code principles can make a difference in test automation?
Sure. Let's say you're trying to debug a test that's failing.
Okay.
If the code is messy and uses cryptic variable names like X and Y, it's going to be like trying to solve a puzzle with missing pieces.
Right.
But if the code is clean and uses descriptive names like customer legend button or order confirmation message, you can instantly understand what's going on and pinpoint that problem much faster.
So it's not just about making the code look pretty. It's about making it understandable and maintainable in the long run.
Exactly. And another key aspect of maintainability is avoiding hard coding. Instead of embedding specific values directly into your code,
okay,
you should try to use approaches like data-driven testing,
mm-hmm.
where the test data comes from an external source like a spreadsheet or a database. This way, if the data changes, you only need to update that external source, not the code itself.
Well, that sounds a lot more efficient than hunting down and changing values all over the place.
It definitely is. And it makes your tests more adaptable, too. Let's say you need to run the same test against different environments, like a development environment, a staging environment, a production environment. With data-driven testing, you can just swap out that data source for each environment without having to touch the test code itself.
That's a great example of how a little planning up front can save you tons of time and headaches later on.
Absolutely.
Now, you mentioned version control earlier. How does that fit into the maintainability picture?
Well, version control is like having a time machine for your code. It lets you track changes, revert back to previous versions if you need to, and collaborate with others without, stepping on each other's toes.
So no more accidentally overwriting someone else's work or losing track of changes?
Exactly. It brings order and transparency to your test automation efforts. Imagine trying to manage a complex test automation suite without version control. It would be chaos.
Okay, I'm starting to see how all these pieces fit together. Clean code, data-driven testing, version control. They all contribute to a more robust and maintainable automation framework.
Yes.
Now, before we wrap up this section, let's circle back to logging. You mentioned different logging levels earlier. Could you break those down for us and explain why they matter?
Absolutely. Think of logging levels as a way to kind of filter the amount of information your tests are generating. At the highest level, we have fatal. This indicates a critical error that just stops the whole test execution. Think of it as, the equivalent of your test screaming, something went terribly wrong, abort, abort.
So it's the ultimate showstopper.
Yes, exactly. For less critical errors, we have the error level. This indicates, a failed condition or an unexpected behavior that, while serious, might not warrant stopping the whole test suite. It's like your test saying, hey, something's not quite right here, but I can probably keep going.
Got it. So fatal is for catastrophic failures and error is for more manageable issues. What other levels are there?
Well, next we have warn.
Okay.
Which is used to flag, potential problems or unusual situations that might not be errors but could indicate an underlying issue. It's like your test giving you a heads up saying, this looks a bit suspicious, you might want to investigate.
So it's like a yellow flag, not a red flag.
Exactly. Then we have info, which provides general information about the test execution, like the steps that were executed, the data that was used, and so on. This can be helpful for understanding, the flow of the test and seeing what happened at a high level.
Okay, so it's like getting a summary report of the test's activities.
Right, and then for the really nitty-gritty details, we have debug. This level provides very detailed, low-level information that's mainly useful for developers who are trying to troubleshoot problems in the code. It's like peeking under the hood of your test to see all the gears turning.
Okay, so we got fatal, error, warn, info, and debug. Is there anything else?
Yes, one more. The most granular level is trace. This provides an extremely detailed log of every single step and action taken during the test execution. It's like having a video recording of your test that you can slow down and analyze frame by frame.
Wow, that's a lot of information. So how do you decide which logging level to use?
It really depends on the situation and the level of detail you need. During development and debugging, you might want to crank up that logging level to capture as much information as possible.
Right.
But in a production environment, you probably want to keep it at a lower level to avoid generating, an overwhelming amount of log data.
Yeah, that makes sense. It's like adjusting the zoom on a microscope to see the level of detail you need. So keep exploring, keep learning, and good luck on that exam.